Alright students, we're going to start vodcast 2.4 on physical and chemical changes. I'm sorry for the quality of the video a little bit. I'm recording it in a different place, and so therefore the fonts and stuff look a little weirder, and there's not going to be any writing on this one. I tried to pop everything in. So we're going to talk about physical and chemical changes. First off, physical changes are those in which the actual chemical composition of whatever we're doing the changing to doesn't actually change. In other words, it's the same chemical at the beginning as it is at the end. And an easy and succinct way to state this is that we change the form but not the formula. Okay, now what does that mean? And here's an example of what this means. So a phase change is sort of the biggest type of a physical change. And you can see in this video here, this is melting ice. And so phase changes include some things that you guys already know about. So melting, okay, where we're going from solid to liquid. Boiling, where we're going from liquid to gas. Freezing, where we're going from liquid to solid, basically the reverse of this. And then condensing, when we're going from gas back to liquid. There are a couple others. There's sublimation and deposition that we'll talk about later in the year. But what's important to realize here is that the formula doesn't change. So as these ice cubes melt into water, it's still H2O. That's the formula the whole time. And if we boiled them off and turned it into steam, into water vapor, the formula would still be H2O. It doesn't change at any point. Okay, it's still just going to be H2O the whole time. So it's the form that's changing, not the formula. So some more examples of types of physical changes. All the phase changes, and we just talked about those. We're cutting or sawing something. We're breaking something into pieces. In many cases, if we're dissolving something, because we can get it back out without a chemical reaction, if we distill something, and if we filter something, and all of these things we've done before when we did our separation lab, but those were all physical changes. The formula never changed. The iron filings were still iron filings at the end in our lab. The sand was still sand. The salt, even though we dissolved it, filtered it through something, and then boiled off the water, the salt was still salt. It's still sodium chloride. So how does this differ from chemical changes? Well, in chemical changes, the actual formula of the products are going to change. So in other words, if we started with water and we did a chemical change, it wouldn't be water at the end. It might be hydrogen gas and oxygen gas, but it wouldn't be water. It wouldn't have the same properties as it had at the beginning, which would be different than a physical change. The properties in a physical change are largely the same. In a chemical change, they're going to be vastly different things. So there are four indicators that this is happening. The first of these we're showing here is the generation of a gas. And this is not the gas like we're boiling something, but this means there's a new gas being created. So in this case, in that video, what's going on is there's concentrated hydrochloric acid down at the bottom of that flask. I threw in some zinc metal. Reaction happens, and in that reaction it generates hydrogen gas, and then hydrogen gas is what's filling up the balloon there. And at some point in the year, maybe we'll blow one of those up. They're kind of fun to blow up. The second and third, really, of our indicators of a chemical reaction are a precipitate and a color change. And this little reaction where we're going to add lead nitrate to potassium iodide is going to show both of those. So had lead nitrate in there, poured potassium iodide. As soon as it hits, first off, it changes color from clear to yellow. And secondly, we get a precipitate. If you look down in the very bottom of this, and it's a little hard to see, but you can see there's actually solid stuff down in the bottom that's starting to fall out of the solution. That is a precipitate. And then one of the last ways, but also a super important way to gauge that there's a chemical reaction going on, is that it generates light and heat. So in this case, we're burning a strip of magnesium, which we'll do in a crucible later this year, because that vapor coming off isn't really the healthiest stuff ever to breathe. But if you light a magnesium strip, you're getting an immense amount of light generated. You're getting a lot of heat generated as well. In fact, if we go back to that first experiment where we dropped the zinc into the hydrochloric acid, if you see here, the temperature at the beginning was in the 20s, around room temperature, and then this is actually about 15-20 minutes later, and it's all the way up to about 65, and that's 65 Celsius, not Fahrenheit. So I mean, it's almost up to boiling of water point at that point, so generating a lot of heat. So again, just to sum up here for chemical changes, the indicators are production of a gas, generation of light and heat, a precipitate, or a color change. doesn't have to be all four of these. Any one of these is a pretty good indicator that there's some sort of chemical change going on. It could be two or three like we had in a couple of these cases, or it could be one, or it could be several. If you see any of these things going on, though, there's a pretty good chance that there's a chemical change going on. So some words to look out for chemical changes: if something is burning, if we say that something is rusting, those indicate that they're changing chemical compositions. Cooking is another thing. You're denaturing the proteins. They're not the same thing anymore. And then, of course, if you see the word reacting, that is most definitely a chemical change. If you're looking at a bunch of stuff and it's asking you if it's a chemical or physical change, one of the easiest ways to tell is that if you can reverse it relatively easily, then it's probably a physical change. This is particularly true for the phase changes, because with the phase changes, remember what's going on is that, we're melting ice cubes, and then at the end, if we're going to go back and we could freeze the water from those and make new ice cubes, so we could freeze the water and turn it back to solid, that would be reversing the reaction. And that's pretty common for a lot of physical changes. If we sawed something, we could put those pieces back together. Even broken things, we could probably put them back together without losing much of what they were. We did that in the filtering and all that stuff in the lab. So those are pretty good indicators of a physical change. As far as we know at this point anyway, if it can't be reversed, okay, like cooking an egg, you can't take that back, then that is more than likely a chemical change, okay? So just keep all that stuff in mind. You might want to run through this video again, or if you didn't pause and get the notes, and make sure you get those and just to see some of those examples again. Thanks as usual, kids.